Very warm welcome to another power-packed session of the 16th edition of Renewable Energy India Expo. This session is powered by JMK Research, and the topic of discussion would be domestic module manufacturing trends in India. The key points of discussion are current domestic manufacturing landscape, market outlook, supply chain issues and potential solutions, impact of PLI scheme on the sector, market outlook again, key challenges faced by manufacturers, etc. And to take the session forward, I would like to call upon stage our esteemed moderator, Ms. Jyoti Gulia, founder, JMK Research and Analytics. A huge round of applause, ladies and gentlemen. Ms. Jyoti Gulia. The first panelist that I would like to call upon stage to join us is Mr. Chiranjeev Saluja, MD Premier Energies. Another round of applause, ladies and gentlemen. Our next panelist is Mr. Sujoy Ghosh, Director First Solar. The next panelist that I would invite to join on stage is Mr. Saha, CEO, Vikram Solar. And last but not the least, our final panelist, Ms. Mirunalini Chellappan, PV Module Division and Special Projects, SWELECT HHV Solar Photovoltaics Private Limited. And now I would request the moderator, Ms. Jyoti Gulia, to take the baton of this session and take the discussion forward. I'm your host, Manu, and the stage is all yours, ma'am. Thank you so much.
Thank you, Manu, for the quick round of introduction. We are here to, the broad agenda has been discussed by Manu already, what we want to see. And without further await, we can start with the panel discussion with our esteemed panelists here. So we can start with, the domestic manufacturing sector has got a huge thrust and push from the PLI scheme. So my first question, probably, Mr. Rivan, is for you, that how do you think the PLI scheme is going to change the market dynamics? What actions are already in place that you have seen in last 1 year? And what do you think by 2025 or 2026 the market will be?
Thank you. Thank you, Jyoti. And my dear panelists and the audience. My name is Saha. I'm the CEO of Vikram Solar. It's a very pertinent question right now, Jyoti. Actually, PLI has transformed the manufacturing space in the last 2 years. There has been a PLI 1 and a PLI 2, two tranches of PLI. And in the last PLI, we have PLI 2 between 1 and 2. One was a smaller volume, but the second one was quite big, about 40 gigawatt. In together, maybe about 40, 45 gigawatt of manufacturing has been committed. And the most important aspect of the PLI is that it covers the entire value chain, starting from polysilicon to modules. And there have been differential rates across the value chain for the PLI benefit that you can accrue over the next 5 years. With the exception of First Solar, all other manufacturers have been in silicon, and First Solar automatically becomes like a polysilicon to a module manufacturer directly. It's like the substrate material is directly coated on glass. So I won't get into the details of how the PLI scheme played out, but what has happened is two things have happened. One is after PLI, a lot of interest in manufacturing has picked up for the silicon value chain. investors um, have good confidence that um, this PLI will be, executed in the final form, and therefore there have been financial closures. Projects have started um, on the ground. Um, Also, it has created in this PLI 2 a whole scenario build-up has happened around ancillaries. Because in PLI 2, the support to the ancillaries also has been given, and that has transformed. So there are a lot of, like, there are 3 major glass manufacturers now. Earlier there was only one, and so on and so forth, backsheet, EVA, aluminum frames. And the importance of that is undeniable, because there is a whole lot of value ecosystem that was missing in the value chain. So that problem probably is going to go away after 2 years, when some of these component manufacturers will get the support from the domestic manufacturers. Okay, this is the good part. Now, what is not so good? The not so good part is, to our estimate and understanding, very few manufacturers will be able to stick to the PLI timelines, which is 18 months if you have a cell and module, 24 months if you have cell module wafer, and 36 months if you have polysilicon to module. With exception of 1 or 2, most of them, the projects are delayed. Financial closures in some cases have been held up. And the reason is, PLI support, while it has been there, but the offtake of the PLI, which is the market development that was supposed to happen, has not happened the way that it was. There was BCD, there was ALMM when PLI bid was there. Subsequently, ALMM was extended. BCD is still in place, but what did the Chinese do? They dropped the prices of cell. The polysilicon prices came down across the whole world. The wafer prices came down. Cells, there was an artificially inflated conversion cost that the Chinese was charging for wafer to cell conversion. Now that they have removed totally. So if you see, effectively, from wafer to cell, there is a 2-cent conversion in China, which is, you can't even imagine. Even the best of the efficient bidders in PLI definitely would not meet that cost. I don't understand how Chinese meet them, but obviously that means that they are absorbing that cost somewhere else. So what has happened is that module has become 14 cents. So 5 cents wafer, 7 cent cell, 14 cent, 7.5 cent cell, 14 cent module, which after application of BCD of 44% is cheaper than Indian-made product, Indian-made module, with imported cells. Now, if you add domestic-made cells, then the gap will be huge. There will be at least a 10-cent gap. Now, what does it do? It has 2 impacts. One is, obviously, projects will have to be re-engineered. You might have to go into higher efficiency. You might have to take fewer risks so that your bottom lines are covered. And then, secondly, investors are getting jittery because of this. Because financial closures will not happen because there is policy uncertainty, which is a big, big key risk. We justified setting up manufacturing under PLI scheme. I think in a nutshell, that's what happened in the last 1.5 years. And it continues now. And we have yet to see, those PLI capacities. My expectation is by 2026, maybe out of that 40 gigawatt, 25, by 2025, about 25, 50% of it will be built. That's my realistic estimate, but that's my personal opinion. Yeah.
Thanks, Ivan, for that. Mr. Sujoy, my next question is for you. Since you are one of the beneficiaries from the PLI scheme, anything you have to add on to what Mr. Ivan has just said on the timelines, and where, First Solar is the only international company who has been part of it. So what are the key reasons for First Solar to, take India as a manufacturing destination? Maybe some insights around that.
Yeah, so First Solar's reasons to invest in India are very simple. It's for us as a company, we don't buy anything from China, we don't sell anything to China. So our global market is excluding China, both from a supply chain and a market standpoint. And so outside of the US, which is our home country, India represents a very large opportunity for us, given that our technology and our company is really focused on utility scale market. We are not participating in the rooftop solar segment, right, which is where Europe's got a lot of distributed and rooftop kind of applications. So one is it's a market for us. Two, at the time we made the investment, our assessment of our cost of production in India was at par or maybe better than our cost of production in ASEAN countries, where we had existing manufacturing footprint both in Malaysia and Vietnam. And given that, those were the two factors. So we got a market. We also had a experience of 10 years of our technology performing here in India, right? From the time of the JNNSM phase 1 batchman. We've been selling our modules to IPPs, and there's a solid 10 to 12 years of operating history in terms of our energy production, which is something which is highly bankable and valued by our customers. And so we have a customer base. It's a market which is growing and will grow more. And from a manufacturing cost standpoint, I think the key metrics for us were fairly competitive as compared to alternate destinations. So those three combined for us. Now, having said that, as Ivan said, we are unique. We don't have dependencies on silicon. And because of that, if you look at our module, I mean, 85% of a module is actually glass. And for us, the semiconductor for, let's say, polysilicon is about 35% of the total value of the module. For us, the semiconductor is like hardly 3-4% of the value of the module. And so creating the ecosystem of components, which is very important in any of the solar manufacturing, as Ivan alluded to, right? So it's a lot easier for us to create our ecosystem of components in a new greenfield country, which might be a deterrent for some of the other well-established global manufacturers to come and replicate, given that what they've created in China, backed with covert and overt subsidies from the Chinese government, that kind of free money is hard to find, in a third country. So I think those two factors will be a deterrent for some of the other large global companies to actually set up full integrated facilities. It's very hard to duplicate capacity if you already have overcapacity in your home country. And so that's the short answer.
Right. So your facility will also be used for global supplies also?
We can, but right now when we invested, our facilities are targeted to support the Indian market. We already have more than 10 to 12 gigawatts of manufacturing footprint in the US. We've got plants in Malaysia and Vietnam, which kind of support other markets. We used to support India out of Malaysia and Vietnam, simply for geographical proximity, but our India investment is primarily for supporting the domestic market.
Thanks, Sujoy. Mr. Saluja, my next question is for you. Premier is also into cell manufacturing. So I want to understand, even with the PLI benefits that an Indian player is getting, what sort of challenges a cell manufacturer is facing, and what can be the challenges on the other wafer and polysilicon supply side? How those will be addressed?
So we, being one of the largest cell manufacturers in India and being an early mover, we have faced quite a lot of challenges. One of the large one was when we set up the line during COVID, and we face that challenge even today that China controls equipment manufacturing. China controls wafer manufacturing. 98% of wafers in the world are made in China. So, and then the Chinese are not able to get visas to come to India. So we overcame all those challenges, started our cell line, which is a 2 gigawatt line now. And the big challenge now we face is, we are dependent on them for wafer supplies. And if you look at the way the Chinese companies work, they don't work on normal business principles. You see wafer prices, if you look at December 22, was $1 a piece. On 10 January, it falls to 60 cents. And July, it goes to 80. August, it's down to 33. Today, it is down to 32. So, we face these challenges because they control this market, and China works on demand and supply. When they have a huge demand, prices goes up, and when there is excess supply, they just clear stocks, dump into other countries. As what Ivan was saying, even BCD doesn't help at that time. Today, look at module prices with BCD are still cheaper than what Indian manufacturers can give. So while the manufacturing industries have learned from this experience, even the IPPs and CNIs in India now understand this, and most of the contracts what we do are wafer variable contracts or cell variable contracts to protect the upside or the downside. But then we are doing fairly well. Nobody expected India to get into mono-PERC cell manufacturing as quickly as we did, and now I'm hearing that TOPCon will also come in within the next 12 months. So we are, catching up with the technology curve. It takes a little bit of time with the challenges which we have in terms of the price competitiveness compared to China. But then what do you compare with China? Do you compare with China when China is in normal situation, or when they are in a distressed situation and they just dump? So you don't even have a neutral bar to compare. But there is a great opportunity for Indian manufacturers, cell and module, for export to the US. And this is something which is, and also the DCR market in India, which is now become viable with the wafer prices going down. So I think we should not stop here, and manufacturing growth has to happen in India so that we can keep building this Make in India program.
Right. One follow-up question, Mr. Saluja. With the IRA, the Inflation Reduction Act in US, there are a lot of domestic manufacturing setups that are expected in US. So how the exports market will, play out in next 2 to 3 years time frame for Indian players?
Yeah, so my view is that a lot of module manufacturing is expected in the US, although it's not going to be easy. I think what has been announced is almost about 30, 40 gigawatts. I would discount that by 50% because it's not easy to set up manufacturing in the US. Sujoy will be able to share more insights. Even to get, I was told, a transformer in US for your factory is like a 24-month waiting time. That is the kind of challenges there. And if you look at the people in US, they are not used to working in 24/7 environment. They are more into software and a different kind of working culture. So, but yes, module manufacturing will come up in the US. I see that, my take is that cell manufacturing will take longer. So there is still a huge opportunity for Indian manufacturers to export to the US, solar cells and modules, because even with the IRR, I think we'll be cheaper than make in US. So as long as the window is open, there's a great opportunity.
Right. Thank you, Mr. Saluja. Mirunalini, thank you for your patience, but you have heard all the other panelists. With you specifically, I want to, understand more on the wafer manufacturing side of the business, how that will evolve in India, if that is going to happen.
Okay, so on wafer manufacturing, though I don't have much of an experience on the wafer side. So the way we see this evolving is that we are again going to be heavily dependent on China, because we don't come from a background of semiconductors or foundries, polysilicon foundries. So primarily we will have to look at strengthening our, the foundry side first, the polysilicon side first, and then come in to talk about wafer manufacturing. And on the wafer side also, we are talking about TOPCon and HJT, which is in the future. So the way forward, what we're looking at is that we should look at securing the technology first. Do we have enough research happening here, enough innovation happening here? Are we really owners of the product, or are we just going to work as assembly lines for borrowed technology where we really don't own it? So the key to the entire value chain being successful would be to heavily invest into innovation, research, and own the technology, which in turn will help us secure the entire value chain, both upstream and downstream, and move forward. Thanks.
Thanks, Pranali. Another question is on the ancillary component that I have for you. Ivan has touched base a little bit on that, that on the glass manufacturing, EV, backsheet, there were very few players, but that industry is evolving. So what are the key trends that you are seeing in that space? And do you think it makes sense to extend PLI even for these ancillary component manufacturers?
Well, for ancillary components, definitely PLI will help, because today, if you look at, yes, the PLI for ingot to foundry to the module is available. Now, the next highest component that go into the module is glass. Backsheet, we don't know. We will be looking at, phasing it out soon. It is going to be glass on glass predominantly. So if you look at glass, frame, EVA, junction box, ribbons, in this, if we categorize them as what are the ones that have high value into the product and also require heavy investment, those are the ones that will need the support for with PLI. And in that comes your mainly the glass, and then frame. These two are the major items where a heavy PLI support might be required. And when we talk about PLI, especially for the ancillary products, as a manufacturer, we are also quite hesitant about, it is always a debate about Indian raw material versus an imported raw material for various reasons in terms of technology, in terms of yield, adaptation, volume, price, etc. So again, I would refer to my previous, answer on innovation. So unless the PLI is linked to innovation and owning the product, owning the technology, that tie should be there for that to be successful. So in short, yes, PLIs for ancillary components is something that would definitely boost, especially for glass and for frame. Frame, I think the major challenge is having the anodization plants as well as the raw material, securing the raw material. So it also needs a certain amount of government's push in terms of securing that as well, especially talking to the other countries and ensuring that the supply chains are there in place. Apart from that, in terms of module manufacturing equipment or cell manufacturing equipment, that is again something that we have not concentrated on. And if extending a PLI for equipment manufacturing would definitely be need of the hour. And what would help is, again, reiterating, would be to tie it up with owning the technology. So any manufacturer who comes under the PLI scheme should be mandated to have a certain amount of the investment going into R&D. And a return on that would be something that would be beneficial to the industry as a whole. Thanks.
Thanks, Pranali. Ivan, since Pranali is touched base on this word R&D, we have heard that PV manufacturing, every few months down the line, the technology is evolving. The lines will become redundant, what already Indian manufacturers have. So what do you think, or maybe how this market is going to evolve in next few years? How manufacturers are going to address these kind of challenges? What R&D efforts are required at Indian manufacturers' side to compete with the Chinese?
Yeah. Uh, very good question. Um, so, first of all, the technology change is a given. Every 12 months to 18 months is a lifetime for a technology. Like today, it's a TopCon with a certain set of processes, maybe 9 or 10 process steps. Tomorrow, that same TopCon process step has to be made 6 or 7, and that involves a lot of R&D, because with the increasing pressure on cost and optimization that is required, I think there are various aspects to R&D that we can talk about. Like, one is fundamental research. Like if you talk about perovskites, if you talk about tandem cells, which is still 5 years away from commercialization. Um, that R&D is better done at universities or research labs. Our horizon of 1 to 3 years kind of R&D, which is more tactical, is on developing processes which can improve your yields, improve your efficiencies, etc. They are done best on first pilot lines and then commercialized on large production lines. Anything which is less than 1 year, there is still R&D, because you need to try out a new combination of paste, you need to try out a new supplier of EVA, which requires a lot of reliability and other tests to be done. That is more and more tactical, and that is best done on production lines, running production lines, in mass scale on big volume. So the definition of R&D and where exactly the R&D, the envelope of R&D, sort of, what is the time frame that you need to cover on that envelope is what needs to be defined first. So today, all the PLI bidders who are going to set up capacity, they need to develop on their own a roadmap for themselves with this kind of time frames in mind. Less than 1 year after you start commercial production, 1 to 3 years, and then beyond 3 to 5 years or something like that. And these R&D efforts have to be very focused. So, and there has to be separate teams. Like if you are doing an R&D on perovskite or a tandem cell, you can't do it on you can't expect the manufacturer to do it. So he has to have collaborations with research institutes or labs abroad or in India, where you can prove the concept first at the lab and then bring it to the fab through a pilot line, scale up, and then commercial deployment. Anything that you do on which can consume more than a year, the next step in efficiency improvement, for example, in TopCon or HJT, which can be done by the in-house R&D team. There has to be a special effort to develop that kind of a team, talent, and do that in-house, and that becomes the IP of the company who owns that that technology at that point of time. Because you get a best-known recipe, a best-known recipe with which you sign off on the site acceptance test of your line. Now from there, if you do not have a roadmap to improve, the general benchmark is about 0.5% every year. 0.5%, thumb rule. 0.5% to 0.6% efficiency improvement every year on the cell. And similarly on the module. If you don't do that, then you will be obsolete. That investment that you have made, the initial, depending on the capacity, the kind of investment that you have made, is going to be defunct very shortly. So that 3-year horizon R&D is extremely critical. and the third one, which is more tactical, also has to be done by but maybe with a different set of people who focuses mainly on the module and paste and doing some kind of material changes which can improve your efficiency and improve your cost. I think that's the broad sense of R&D that I can bring in uh, by, by being there in the industry for quite some time.
Thank you, Ivan. No, that's useful, I think, for the audience also. Maybe Sujoy, you can also share some bit of trends, technology trends that you see on that you foresee in the thin film side of the business.
Well, I think we say the future of PV is actually thin film. The reason is, as you look at next generation materials, they all have to be deposited. Whether it's perovskites, whether when you make a tandem cell, when you're making multi-junction devices, you will have to go outside of silicon. And when you do that, you're looking at how do you deposit semiconductors, into the device. And so that's our view. Of course, again, as I've said, we are an outlier in this industry because we have a completely alternate value chain. But the way we look at the evolution of our technology is really going into multi-junction, like tandem devices. We are already working on it. We've also acquired, I think both Ivan and Mirunalini made the point about IP. We own our own IP, right? I mean, so the technology which we use to make modules is owned by us. And the manufacturing technologies where, we're making the process equipment to, either deposit or metallize or even assemble the module. All of that's co-developed with the OEMs. So there is a joint sharing of IP, but that helps us to also kind of protect the IP going forward. And so we own our own IP. And for us, as I said, we've recently acquired a company in Sweden called Evolar. This is public knowledge. So they hold the world record efficiency on CIGS. In addition to that, they do a lot of work on perovskites. So a logical path for somebody like us is to actually look at, tandem and perovskites, and that's what we're working on.
Thank you, Sujoy.
I have a question for Sujoy. What's the roadmap that you see for your module size and efficiency in the next 2 to 3 years?
The module size won't change. Our module is 2.3 meter height by 1.215. Any change in module size means you have to scrap our process equipment and retool the whole factory. So based on that size, I think we are looking at efficiencies going up to around 20.5 to 21% over the next 3 to 5 years time frame, with additions to the process. But also, I think, Ivan, we've always focused on long-term reliability and energy as opposed to nameplate efficiency of the module. And so there we are doing to do very significant improvement. We're looking at technologies where in the next 2 years, we might have actually literally 0% degradation over lifetime on the module. And so at the end of the day, the value to our customers, which are mostly IPPs, is kilowatt hours per installed kilowatt. And so we really focus on the watt hours, not so much on the efficiency. But I hope I answer your question.
Yeah.
Thank you, Sujoy. Mr. Saluja, my next question is, Mirunalini has touched a little bit on the wafer manufacturing, but you being a cell manufacturer, I think the end game is around wafer manufacturing in India. How will that evolve? How will that happen?
So I think it's a very important piece in the whole supply chain. It's very difficult for India to get into polysilicon quickly, and the thing which we should actually focus on, and I think the PLI scheme also was skewed, we should have focused more on wafer because China controls 98% of wafer, as I told you. The US has been very, very systematic in the way they are working, where They have announced that within 12 to 18 months from now, they will stop allowing Chinese wafers to be used. It has to come out of China. And I think that is the number one goal, that we get the wafering out of China, because that is the largest control they have. And we have also heard no concrete information yet that China is internally discussing not to supply equipments for wafering. They want to hold this technology, so it's becoming a kind of a war now, that they don't want to give equipment outside China, nor do they want to share the technology. But we are not very sure. There is still no clarity on this. All the technologies which China has, grown on and created the market and created the scale, never came from China. It was given by the Europeans and the Americans, and also partially India. So I think that it's very, very crucial, and it's like the most important thing, that the manufacturers outside China should set up wafering immediately. And P-type or N-type is not a challenge, or even HJT. The wafering equipment is common for P-type, N-type, and HJT. There is no different equipment. We lost the bus because we always had this challenge of getting low-cost power in India. Substantial portion of wafer manufacturing is low-cost power. Today we are, I think, there. We are able to get power in India at $4.50 a unit, which is similar to what is in China. So there's no reason why we should not set up wafering lines immediately. Huge opportunity for even US market, and also for having energy security, where we can then buy polysilicon, which is raw material for wafer, from outside China. So if you look at the whole thing, there is about 15 to 20% of polysilicon which is made outside China. And this is by the likes of Wacker, Hemlock, OCI. And these polysilicon manufacturers also have no choice but to sell their polysilicon to China, because there is no other wafering facility other than what is in China. So we need to break this control and get into wafer manufacturing as soon as possible. So every meeting at ministry, we keep pushing them that come up with an exclusive PLI scheme for wafers, and we should really focus on wafer manufacturing.
Thanks.
Can I
Ivan,
add
yes.
something on this? Because, see, wafer manufacturing, if you break down the costs of conversion of polysilicon to wafer, we've done that number of times over the last 2 years. It's not competitive in India today, without any government support. Not competitive. You can't have 5-10 gigawatt of wafer capacity and beat the cost of LONGi or 60-70 gigawatt manufacturer based out of China. Principal reason is what Chiranjeev said, is the cost of power. As you are going up the value chain, the contribution of power costs in the conversion cost goes up dramatically. In polysilicon, it is about 50%. In wafer, it is almost like 25%, 30%. In cell, it is about 20%. And then in module, it's hardly about 12% or something like that. So the cost of commercial power in India today is extremely high. Yes, solar power is available at 2.5 rupees. But how many manufacturers are actually who have planned to set up will be 100% supplied by renewable power? No, hardly any. So the PLI support for CapEx is one thing, but we need beyond that. On power subsidies, on CapEx subsidies, and on other conversion subsidies like water and those kind of things, which can make the wafer competitive. I mean, otherwise, wafer made in India cannot compete with China today due to economies of scale or the other peripheral reasons that I talked about. Unless you put a BCD on wafer, with Chinese wafer, yes, then you can be competitive. This is today's situation. So the capacities that are going to come up, they're going to really, of course, many people have bid for wafer capacities in PLI too. They will have to really work out of their skins to make wafer competitive as a standalone business. Or else you have to spread your that cost over the entire cell and module business in order to make margins on the whole.
Correct. Absolutely. So, Mrinalini, my last question to you before we open up for the audience, maybe. We have seen there is an extension on ALMM for last 1 year. What was the short-term impact that you had, and what is it you are expecting that ALMM will be extended? We are hearing those rumors. So, how that has impacted domestic manufacturing in last 1 year?
Okay, so as long as ALMM was there, for it was a great way of protecting the Indian manufacturers. It acted as a barrier, against the imported modules. And I think everybody whoever was a manufacturer in India really had their heyday during that time, those couple of years. But now that ALMM has been removed, there have been multiple challenges that are being faced by domestic manufacturers. So first and foremost is, I think, many of the in the risk profiling. First of all, when you look at funding and the risk profiling there, then definitely this is given a big hit to the domestic manufacturers, because ALMM did give a very secured offtake for the Indian manufacturers, and now that has been removed, and which has opened up the market to the safeguard against both the price protection as well as the offtake protection is gone. So which means that in the risk analysis, the risk in the manufacturing has gone up substantially in terms of from funding. Then secondly, what we are also seeing is the drop in prices. So multiple reasons are there, like what Mr. Ivan said and my peers said here. But beyond that, definitely a drop in prices has also impacted the market a great deal. And it has also led to a lot of projects taking off, but at the same time, people are also in a wait and watch mode. And we do not expect ALMM to be, come into effect in March. Even though as a manufacturer, we would wish for that to happen. But the way things are going, the market news is that it might get extended by another year. So which will be a big setback to the manufacturers, because the protection is not there and the capacity utilizations might come down substantially. And of course, the team, everybody will be looking at the export market as an alternative. What could have been done, which we are also representing to the ministry, is that we understand the manufacturing in India is not substantial or sufficient to satisfy our 450 gigawatt target or 500 gigawatt target, whatever we've taken. But to the extent to which the capacity is available and to the extent to which they need to import, a certain percentage of the projects that take off should have a clause that says that this much percentage, let's say Indian capacities can only cater up to 30% of the requirement of the targets taken. Then every project should say that 30% should have an ALMM or Indian manufacturer, and the rest can be open. And there should be some kind of a price protection scheme that comes into the market. So we are hoping these inputs are taken, and against what the market says, we are still hoping that ALMM comes into picture by 24. But yeah, thanks.
Yeah, hope for the best. Though with my interactions right now at REI Expo, everyone is saying their line is completely booked for next 1 year. So most of the domestic manufacturers are talking. The smaller ones, I would say, more. Yeah. But yeah, the forum is open now for questions from the audience. Anyone? Any questions? Can someone pass on the mic?
Thank you. So my question is really for all of you on the panel. I'm following up on the LMM question. I'm curious what your take is. Like, will we see LMM coming into effect in March 2024, or what's your take on it? Thank you.
Could you introduce yourself?
I'm Nicholas Loa. I'm an analyst for solar at Opus Dow Jones.
So the question on ALMM is really important for us. It's not that we're expecting, we want ALMM to be brought back, because it was very, very important to counter the challenges which we face with regards to dumping from China. I mean, it's really, it's not that we're against Chinese producers, it's just that the method of the business strategy which they have in terms of dumping when they need to dump and increasing prices. I mean, if you look at the IPPs in India, who are some of the large independent power producers, not a single IPP would say that they have not had an issue with large Chinese module manufacturers negating contracts after signing. So, the kind of, if the prices go up, they just cancel contracts. So there's no normal business protocol which is maintained, and no developer would want. I mean, today the situation is such, when I buy silicon wafers from China, my understanding and my team's understanding is till the time those wafers are not loaded on the ship and left from China, they don't belong to me. Because they can just cancel the contract 24 hours before the wafers are boarded and say prices have gone up, and then we cancel the contract. So how do you work in such an environment? We don't have this kind of protocol in India where we sign up contracts and then we back out. So the IPPs understand this, and we as manufacturers want the ALMM to come back at any cost. We need to fight for it and get it, because only then we are able to have a level playing field. We invite the Chinese manufacturers to come and produce in India. They're most welcome to come and set shop here and produce and have a level playing field. If you look at PV InfoLink, if you follow that, just about 3 weeks ago, wafer prices were 40 cents and cell prices were 9.5 cents per watt peak. And then wafer prices went up and cell prices drop. How is that possible? How can your raw material go up and the finished good price drop? So these are the challenges we face, and we would want a normal working environment in India where we are able to have a stable supply chain, and delivering modules to our customers here. And this is the reason why we really want that ALM should come back. We also have a challenge if ALM doesn't come back for FTA countries. The US has investigated, and publicly the news is available, where Chinese producers have circumvented, produced solar panels in Vietnam, brought them from China, and just shipped to the US. So even if there is a BCD and prices go up in China, they can always get it back from Southeast Asia. So ALMM will stop all this, and it's very crucial for us to get ALMM back. Otherwise, Make in India will really get delayed by a couple of years.
Thanks, Mr. Saluja. Any other questions?
Yeah, hi. I'm Aryan. I'm a recent graduate from YMCA Faridabad, and I've done my internship at IMEC Belgium. So there's a quick question in my mind, since you all guys are into manufacturing. So there's a vertical in manufacturing called sustainability. Suppose 20 years down the line, when we look at panels, when the people will be looking at panels, there will be a question in their mind that what was the sustainable products that were used in manufacturing, or maybe that has caused e-waste generation maybe 20 years down the line. So are you guys planning or doing something around these two things called sustainability and recycling at this moment? Thank you.
Yeah, I think let Sujoy give his views on the cadmium telluride part of it. But from our side, on the silicon, yes, we do care for the environment. We have we choose raw materials which are ROHS compliant, which has minimum e-waste generation numbers from their data sheets. We choose suppliers and we do supplier audits based on that. We just don't believe the data sheets, we do supplier audits. As far as, and we ensure also what is the, for every kilowatt that you produce of solar panels, how many kilowatts of energy do you consume, starting from the polysilicon? We keep track of that, not for every order, I would say, but at least at a overall, on a quarterly level or a monthly level, based on the volumes that we produce. Just to keep the, our equation clear on the additional carbon that we are using to, because we are using, making a product which is renewable in nature and supposed to reduce the carbon footprint. We shouldn't add to the carbon footprint. So that's part of our policy, which is, in Vikram Solar, we have those policies inbuilt, which helped us to, a lot of our customers do this kind of environment audits, carbon credit audits. And we not only do this ourselves, we get it validated by external agencies. EcoVadis, for example, one example. That is on the sustainability part. On the circular economy, yes, so there is, everybody recognizes it's a mounting concern of tons and tons of e-waste from, recycling of solar modules, junk solar modules. India's installations started from 2020 to 2010, let's say. The first set of projects that were built under JNNSM, 2010. So 25 years, which is 2035, you will have a few tons, a few hundreds of tons of solar modules that need to be taken off and disposed. And that number will go exponentially high over the next 15 years, till 2050. I remember I had done a study on this about a year back, and the numbers were really astronomical. So there are now few companies in India. Of course, this is a norm in Europe, where we sell. In Europe, you need to have circular economy. I mean, you need to have a plan for recycling. You are part of a PV cycle program. Unless you are part of that, you can't sell a product to Europe. A PV cycle is a company which takes care of the end of life recovery of the modules. Such a process is not there in India today, but there are a few companies who've come up now, a couple of companies in Chennai and elsewhere, who are actually focusing on extracting value from the recycled modules, mainly the silicon, the silver, the aluminum. As far as the aluminum and glass is concerned, is fairly easy, but getting silicon out of the module or getting silver out of the module is a little cumbersome process. There are many processes actually by which they can be done, but serious thoughts are going on now on this aspect, which we are in fact sponsored a few projects on this as a manufacturer for the keeping an eye on the future. But we'll have to integrate more of this in the future, yeah.
And just adding on to Mr. Saha's before it goes to Sujoy, definitely what kind of raw materials, in the process what happens, and then end of life what happens. But one major item that viewpoint that we also have here is that the cost of poor quality, COPQ. So when a module is designed to function for 25 years, now 30 years of design life and guaranteed. Design is, of course, as long as, till the silicon degrades. So are you designing your module and the raw material that go into it are they good enough to function for the entire 30 years, what we are guaranteeing? Today, if you see, most of the modules that are in the field, especially the ones before 2015, before the EL machines came into the line, most of them are failing much before their design life, much before even their 10 years of operating life. So that is also another important factor that, as manufacturers, we are very careful about, and every manufacturer, I'm sure, is the COPQ, and are you are you having the right raw material? Are you following the right process to ensure that the module serves its lifetime and then goes into end of life? So that's another critical factor. Thanks.
Thank you. We have 2 more questions from the back.
Hi, my name is Anu Bhambani from Taiyang News. We are an online solar PV technology and news portal. I have 2 questions. One, as you mentioned that, wafer equipment, the Chinese government there are rumors, unconfirmed reports that they may be, they're not very willing to pass on the technology to India. So till the time, this happens or there's some clarity, possibly it happens, what is plan B for Indian manufacturers? And second question is about the falling module prices. The talk that we have had with companies at REI, they're saying that it is obviously the module prices are so low that even the BCD doesn't really work. So and we've seen that in Europe, the warehouses are full of Chinese modules right now. So yes, some of the module capacity that is going to come in, till March is going to be used for some projects that are in their backlog. But how much do you think will end up in the warehouses? How much do you think that installers and developers are going to hoard for this year? Thank you.
So for the wafer manufacturing equipment, plan B is that there are certain companies in America, in Europe and Japan which have the technology. If need be, they can supply equipment. It would take a little longer, but it's possible to get equipment for wafer manufacturing. There will be challenges, but it's not a showstopper. We can work around in terms of wafer manufacturing. And your second question on module prices, yes, we know that warehouses in Europe are full of modules. That would not apply here, even if you have ALMM getting implemented on 1st April, the MNRE exemption is only for projects which will get CIEG connection, and the project should be connected to be able to use those modules. So if certain developers import modules, but they're not able to connect the projects, then I think they'll have to ship those modules to Europe for further stocking because they cannot use it in India. So there is a clause there where you cannot keep those modules and use them. But I really don't see, in India we have seen that this policy instability and confusion, it continues. So even if this has to be extended, the LMM, it will be extended maybe for 3 or 4 months on 1st of April, which will be of no use again. So I think ideally we would really push that ALMM is implemented and we are done with the story and focus on local manufacturing and stable prices. So what is happening now with module prices dropping in China is not just to the solar industry. If you look at what's happening in China is something really big. If you look at the whole economy, what is happening in China, they are in a really bad shape now. So every sector in China is facing the heat.
Thank you. We can take one last question, please.
Myself, Dinesh. I am from Hyderabad and then working as business analyst in Atri Energy Transition. For that, food and energy is the never-ending question for us. Another one is when we can expect the concentrated solar cell manufacturing in India, because land was the major problem. And another one is India is going to be the green hydrogen hub. Concentrated solar cell, it will help to decrease the cost of power and increase the export for the green hydrogen.
Your question was when will concentrated solar power (CSP) come into India?
That was when will.
Okay. So well, very difficult to say. I don't know of any manufacturer who's in India right now talking about CSP. CSP, I think the first JNNSM phase 1, there were 1 or 2 projects that were implemented with CSP technology imported from Spain in Gujarat. But after that, there are no projects in India who has incorporated CSP. CSP in Indian geography, I mean, it is successful in Mediterranean region, Spain, Portugal, I mean, Southern Europe and North Africa, where there is a lot of direct insolation, you know, DNI, which is required for CSP to really flourish. In India, the problem is we have DNI, we have good sunlight, but most of it is in many months, at least 4 months, it's diffuse light. When you have diffuse light and CSP doesn't come up with that kind of efficiency, or it doesn't work with that kind of finesse. So that's the reason I have not heard of, probably people have evaluated it. I'm not aware of any manufacturer who's planning to go in that route. Does that answer your question? Thank you.
Yeah, we can take one quick question from the.
Hey, hi. This is Vishal. I'm working with an investment firm. So basically, my question is related to conversion cost, which you were saying that from wafer to cell. Now there's just 2 cents of cost from 5 to 7
as of now
basically. So can you give some idea? Yeah, can you give some idea? Complete conversion from polysilicon to module. What is the conversion cost? What was the earlier conversion cost? And currently, what is the cost? Right now, we are talking about from 5 to 7 cents. Earlier, what was happening basically?
In India or in China?
In China, basically.
In China, see, the thing is, Chinese costs, I mean, I don't know, maybe God also can't answer that question, that how do you decipher Chinese cost? What you see in the market is the Chinese were making margins on cell in excess of 35 to 40% when they were selling cells at upwards of 14, 15 cents. That price of cell has come down to now 7.5, 8 cents. Yeah. So that margin has gone away. Now, out of that, have they sacrificed some of their costs into that margin now? Nobody knows. Ideally, on a 10 gigawatt scale, ideal conversion cost, according to at least our calculation, in Indian context, wafer to cell conversion cost should be anywhere between 3 to 3.5 cents.
Understood.
Okay, 3.5 cents if it is, or maybe 4 cents. 3.5 cents if it is really competitive. That is the ideal conversion cost. But beyond that, now obviously when the conversion cost, wafer was 5 cents and they were charging 12, 13 cents, then that 7 cents, 8 cents, out of the margin was of good fat 5, 6 cents. You understand? So now that margin has gone. But whether their cost is really, in order to do a conversion plus margin of 2, 2.5 cents, their conversion cost has to be at least, they have to save at least half a cent. So 2 cents mein hona chahiye conversion. But I don't know how that is done today.
Are there any other questions?
Thank you so much to all the panelists. Over to you, Manu.
Thank you so much, ma'am. After this brilliantly refreshing panel discussion and a very vibrant question and answer session, I would like to show appreciation towards our esteemed guests, the panelists and the moderator, for their astute observations and contribution to our knowledge in terms of domestic module manufacturing trends in India. To show our appreciation towards them, I would like to present mementos to all the panelists, and I would request our esteemed moderator to please hand them over on our behalf. Thank you so much. Ms. Jyoti Gulia, ma'am, the moderator, founder, JMK Research and Analytics. Huge round of applause. Please keep the claps coming. The first panelist that we would like to present memento to is Mr. Chiranjeev Saluja, MD, Premier Energies. The next panelist that I would like to invite for presenting the memento is Mr. Sujoy Ghosh, Director, First Solar. The next panelist that I would like to invite is Mr. Ivan Saha, CEO, Vikram Solar. The next panelist that I would like to invite is Ms. Mirunalini Chellappan, PV Module Division and Special Projects, SWELECT, HHV Solar Photovoltaics Private Limited. And last but not the least, our lovely moderator, Ms. Jyoti Gulia, founder, JMK Research and Analytics. I will be presenting the memento on behalf of Informa Markets for, as a token of our appreciation for the contribution that she made today. Now, may I request the moderator and all the panelists to please stand up for a group photograph so that we can capture this beautiful moment. Thank you so much, everyone. On this note, we would conclude our session for now.